Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0113, pertains to the intake air temperature IAT sensor circuit reporting high voltage. This code indicates that the voltage value from the IAT sensor exceeds specified limits, which can lead to issues with engine performance. The IAT sensor plays a crucial role in determining air density, which affects fuel mixture and ignition timing. Positioned typically near the mass airflow MAF sensor, the IAT sensor monitors the temperature of the air entering the engine and sends this information to the Powertrain Control Module, PCM. When the PCM detects abnormal voltages, it triggers this specific DTC. Accurate readings from the IAT sensor are essential for optimal engine performance and efficiency. The intake air temperature IAT sensor is a vital component located near the mass airflow MAF sensor. Its primary function is to measure the temperature of air entering the engine, providing crucial data that the Powertrain Control Module, PCM, uses to adjust the air-fuel mixture for combustion. When the voltage output from the IAT sensor exceeds 4.92 volts, it signals that something is amiss, leading to the triggering of Diagnostic Trouble Code P0113. This high voltage can disrupt PCM operations, which may affect overall vehicle performance. To rectify any issues, a thorough understanding of the IAT sensor's operation and its connection to the MAF sensor and PCM is necessary. There are several possible causes for the P0113 error code. First, a faulty IAT sensor itself could be the culprit, as wear and tear over time can lead to erroneous voltage readings. Second, wiring issues such as damaged, frayed, or corroded wires can impact the ability of the sensor to communicate effectively with the PCM. Poor or loose connections at the MAF sensor, IAT sensor, or even at the PCM can contribute to abnormal voltage measurements. Lastly, intermittent failures can occur due to these wiring issues, emphasizing the need for a comprehensive inspection of the entire circuit to ensure reliable operation. Identifying the specific cause of the high voltage reading is essential for effective troubleshooting. Symptoms associated with a P0113 DTC typically include the illumination of the check engine light on the dashboard, signifying an issue needing attention. Additionally, drivers may experience poor engine performance, which can manifest as rough idling, hesitation during acceleration, or overall sluggishness. Increased fuel consumption is another potential symptom, as the engine may go into a richer fuel mixture to compensate for incorrect temperature readings from the IAT sensor. Monitoring the vehicle's behavior after this code is triggered can provide further insights into underlying issues. Proper diagnosis not only resolves the DTC, but also leads to enhanced driving experience and fuel efficiency. To initiate troubleshooting for DTC P0113, start by turning the vehicle ignition to the on position without starting the engine. This allows you to prepare for diagnostic testing with the Honda Diagnostic System HDS. Use the HDS to check the parameters of the IAT sensor, specifically focusing on the current voltage readings. Under current conditions, the output voltage from the IAT sensor should not exceed 4.92 volts. If the observed voltage is equal to or greater than this threshold, it suggests a duplicated failure, enabling you to proceed with the subsequent testing steps. Conversely, if the voltage is within acceptable limits, it indicates intermittent issues that warrant further inspection of wiring and connections. For the second troubleshooting step, first, turn the vehicle ignition to off-lock mode to ensure safety during the procedure. Next, disconnect the MAF sensor IAT sensor 1 5-pin connector. After disconnection, Utilize a jumper wire to connect terminals A and B to conduct a specific test. Terminal A corresponds to pin number 4 of the MAF sensor IAT sensor connector, while terminal B corresponds to pin number 5. Once connected, turn the vehicle to the on mode and again assess the IAT sensor voltage via the HDS. If the voltage exceeds the 4.92 volts threshold with the jumper in place, proceed to the next diagnostic step. If not, replacing the MAF sensor IAT sensor 1 is recommended to resolve the error. In this third step of troubleshooting, the process begins again with the vehicle turned off, lock for safety. Remove the jumper wire utilized in the previous step from the MAF sensor IAT sensor 5-pin connector. Turn the vehicle ignition back to the on mode, ensuring that the MAF sensor IAT remains disconnected. At this stage, measure the voltage between the defined test points. Test point 1 is the pin number 4 of the MAF sensor IAT sensor connector, and test point 2 is the vehicle's body ground. You should be looking for a standard voltage level close to 5.0 volts. If this level is achieved, it indicates the wiring is sound, allowing you to advance to the next testing step. If not, further investigation is warranted to locate any faults within the wire path. This step commences with the ignition turned to off, lock mode again for safety. Next, use the Honda Diagnostic System HDS to perform a short circuit SCS line test. After creating the short, disconnect the PCM connector C, which consists of 51 pins. Follow this up by checking for continuity between the designated test points. Pin number 5 of the MAF sensor IAT sensor 1 5-pin connector and pin number 31 of the PCM connector C. Confirming continuity indicates that the SG2 wire is intact and properly conducting. If continuity is verified, it's also a good idea to check that the PCM has the latest software version. This can solve some communication issues if it did not. However, if continuity is absent, you'll need to repair any open circuit in the SG2 wire to restore proper signaling. In the final troubleshooting step, ensure the vehicle's ignition is turned off, lock, once more for safety. Proceed by jumping the SCS line via the HDS, similar to previous steps. Disconnect PCM connector B, which also has 51 pins. Focus on checking continuity between test points. Pin number 4 of the MAF sensor IAT sensor 1 connector and pin number 51 of the PCM connector B are your targets. If continuity is confirmed, it means the TA wire is operational. Updating the PCM software or substituting with a known good unit may resolve the DTC if it persists. Should the DTC clear post-update or substitution, you can consider that completed. If continuity is absent, this necessitates an inspection to repair any open circuit in the TA wire to restore the connection. After performing all necessary repairs and replacements related to the P0113 code, it is essential to verify that the vehicle is functioning correctly. Begin by clearing the Diagnostic Trouble Codes, DTCs, using the HDS, which resets the onboard diagnostic system. Following this, take the vehicle for a thorough test drive under various conditions to ensure that the engine operates smoothly without any anomalies. Monitor the dashboard for any re-illumination of the check engine light. Upon completion of the test drive, rescan the system using the HDS to confirm that no DTCs have returned, particularly P0113. Successful verification not only indicates the problem has been resolved, but also reassures that the vehicle's performance has returned to optimal levels. To prevent the recurrence of DTC P0113, regular maintenance plays a pivotal role. Start by routinely checking the integrity of wiring associated with the IAT and MAF sensors. Ensure that all electrical connections are clean and tight to avoid any signal interruptions due to corrosion or loose wiring. Additionally, consider periodic inspection of the sensor functionality, as changes in environmental conditions can affect their performance. Updating the PCM with the latest software can prevent communication issues and enhance the overall vehicle performance. Establishing a maintenance schedule that includes these checks can significantly reduce the chances of encountering this problem again in the future. In conclusion, understanding the function of the IAT sensor and its impact on engine performance is essential for Honda Fit owners. Regular checks for out-of-range voltage readings help in early identification of potential issues. This involves thorough inspections of the associated wiring, sensor connections, and continuity tests to assure the integrity of the electrical circuits. By diligently following troubleshooting and preventive maintenance steps, drivers can prevent unnecessary vehicle downtime and ensure optimal performance. A proactive approach to vehicle maintenance not only resolves DTCs efficiently, but also enhances the longevity and reliability of the Honda Fit. Please like and subscribe to the channel. See you next time.